Okay, you guys ready to see this?
Yeah.
Okay, so I've drawn the picture. Got a lawnmower, it has a mass of 12 kilograms being pushed by a force of 150 newtons horizontally, which means sideways. So I got 150 to the right, we'll say. 40 newtons down. So these are the two applied forces. Shall we just call them like F1 and F2? If the kinetic coefficient of friction is 0.9, find the force of friction acting on the lawnmower. So we are solving for the FF. Okay, I think I saw almost everyone went, okay, well, at the very least I can do this. So FW is equal to mg. So I have 12 times minus 9.8. Does it have to be minus 9.8? It should be. Do you get a feeling that the directions are going to matter here? Positive and negative, you should. 12 times 9.8. I got 117.6 minus 117.6, right? Now, you should realize that the normal force is being affected by this 40 newtons down, right? As you push down, you're actually, like, you're adding weight, really, right? You're increasing the normal force. The way I showed you how to do this the other day was to say that the F net y is equal to 0 because it's just sitting on the ground. It's not accelerating up or down or anything, right? And that's made up of weight force plus normal force plus this F2. Right? There is no, I just went through it, Hannah, and you weren't watching. Okay? F net y. You've got to stay with me, Hannah.
So I put F2, you put FA.
Yeah, FAY, sure. Yeah, absolutely. Call it what you want. The net force up and down is 0 because it's not accelerating up and down. It's a lawnmower on the grass, right? It's not flying up into the air or falling into the ground. It's 0. And that F net y is made up of, I'm doing it again, Hannah, it's made up of the weight force plus the normal force plus the FAY, or the F2, the 40 newtons. So let's plug in what we know. We got 0 is equal to my weight force minus 117.6. I'm solving for normal force, Fn, and the F2 is the 40. And that 40 should be negative, exactly. Okay? So you're actually making a bigger Fn, right? So I'm going to take the 117.6 and the 40 to the other side, and I'm going to get 117.6 plus 40 is my normal force, and my normal force then is 157.6 newtons. Right? Mu equals FF over Fn. Let's try that again. Mu equals FF over Fn. The mu value was 0.9. It's apparently on gravel. Solve for friction force. Normal force 157.6. So you multiply by 0.9. $141.8. Is that what you got?
Yeah.
Good for you. So really, there's not a lot to it, right? It's pretty straightforward once you sort of see it. And then the next part is find the acceleration of the lawnmower. Okay, well, let's go back to our diagram. Now all I really care about is the applied force and the friction force, right? And so I'm finding the acceleration. I'm talking about the x acceleration. So the net force horizontally, the net x force is going to be my applied force plus my friction force. 150, and the friction force is 141.8. So you get a net force of, is it 8.2, is that right? Which means this thing actually has an acceleration, which is kind of weird. Most people, when I cut my grass, I don't accelerate from one end of the lawn to the other. I sort of move at a constant speed, right? No one sort of starts really slow and then goes as fast as they can, increasing in speed. Probably not the best method for cutting your grass. .68 meters per second squared. Okay, good, Braden? Not too bad? Okay, I'm going to come around with a new set of cards. Okay, two people are pushing horizontally on a crate of mass 50 kilograms, but they're not very smart because they're pushing from opposite sides. One's pushing from the right with a force of 50, so from the right, that means to the left. The other is pushing from the left, so that means to the right with a force of 80. The coefficient of friction is 0.3. Find the acceleration of the crate. Now, if there was no friction at all, which way would this thing go? To the right, right? So some people just, if you want to just say the applied force is going to be 80 minus 50, the applied force is 30 newtons to the right, right? Like, you should see that. Okay, so then let's find the weight force, mass times gravity. 50 times minus 9.8, which is 490, right? Which means, therefore, 3 dots, our Fn is 490. Mu equals Ff over Fn. The mu value is 0.3. Solving for friction, normal force is 490. Oh, I think I just started up another. Yeah, I did. Friction force 0.3 times 490. Someone help me out here. 147? Yeah. Because I've done this question 1,000 times. 147, that would be to the left, but I've only got what? 30 newtons to the right. So really, what's my net force? The net force is going to be, we'll say, Fa plus Ff is 30 minus 147. The net force is really minus 117. But does this thing go backwards this way? That doesn't make sense, right? So really, this 147, that's why I do this problem. That 147 is actually the maximum friction force. Friction is kind of like teenagers. They only have to do as much. They only do as much as they have to. A little smile out of people. Yeah, it's just a little joke. No big deal. I'm not offending you, I hope. Okay. So friction force is not actually 147. The friction force is actually what? 30. And so the net force is 0. Therefore, acceleration is 0. It's a bit of a trick question. Okay. If you followed through with minus 147 and then found an acceleration, you would get probably 3 out of 4, right? But you should realize that the friction force does not cause this thing to go backwards, right? That doesn't make sense if you can stop and think about it. You may not have sort of picked up on that as you went through it. Let's draw the picture for this one. So there's the wall. Here's the block. It's 0.5 kilograms. It's being slid up a chalkboard with an applied force of 6 newtons upwards. So we'll call that F1 is 6, and F2 inward is equal to 2. The coefficient of, now which way is friction going to be? How come down? You're right, because it's going up, right? So the friction force is some unknown value that way. We know that the mu value is 0.4. Is there a normal force? There is. Oh, not only is there friction down, but there's also gravity down. And which way is normal force? Yes, opposite the board, perpendicular to the surface. So it's a little bit weird. Okay, so we got F1 is 6 up, F2 is 2 in, the mu value is 0.4. Friction and the weight force are both down, and the normal force is to the left. I'll go through it quick here. But okay, first of all, the weight force is 0.5 times 9.8, which is minus 4.9. So that means that our F net y Well, I gotta know what the friction force is, right? Mu equals Ff over Fn. My Fn is actually equal to my F2 here, right? The normal force is not the weight force. The normal force is actually equal to that value of 2. So mu equals Ff over Fn. 0.4 is equal to the friction force times 2. So friction force then is 0.8, and that's actually negative, it's down, right? Which makes our F net equal to, we'll call it F1 plus the weight force plus the friction force. So it's 6 newtons up minus 4.9 minus 0.8, which gives us an overall net force of only 0.3, right? And now F net is equal to MA. 0.3 is equal to the mass of 0.58. Don't get fooled, you guys, when you're dividing by 0.5. That's not cutting it in half. Dividing by 0.5 is actually multiplying by 2. 0.6 meters per second squared. Okay. You want a new partner for the last one, or stick where you are? Number 12 is the granddaddy of them all. Mix it up? Okay. Okay. So I'll read the question here. I agree, it's a little bit worded, a little bit weird. You're not quite sure what's going on. A puck of mass, 0.3 kilograms, is sliding along an essentially frictionless patch of ice at 6 meters per second. It encounters a rough patch of ice, like we all do in life, like I said to these guys over here. Right? We'll slow down a little bit. But coefficient of kinetic friction is 0.1. How long will it take for the puck to stop, and how far will it travel? So you should realize that the mass is 0.3. The initial velocity is 6, and the final velocity, because it's coming to rest, is 0. And the mu value is 0.1, right? So really, all that's happening is friction is slowing this thing down. That's all that's happening, right? Friction is slowing this thing down. So, what is my weight force? Mass times gravity, 0.3 times minus 9.8, 2.9. Therefore, the normal force is positive 2.9 because there's no other verticals. Mu equals Ff over Fn. 0.1 is Ff over 2.9, giving me a friction force of 0.29, right? And that is my net force, mass times acceleration. So that's my 0.29. The mass is 0.3 times the acceleration. You should get an acceleration that is essentially equal to 1, right? I actually got minus 0.97 is what I used. Okay? Probably depends on how you round this 2.9 here. Then that goes into Vf equals Vi plus At. Final velocity is 0. The initial is my 6.97 t. And so you get a time of 6.12 seconds, just roughly more than 6. And once you've got that, then you're going to go d equals Vit plus a half At squared. Say it. Don't do that. I'll combine it. What's the initial velocity? 6.12 plus 1/2 of minus 0.97 t squared. And you should get, well, I have 19 meters as my thing that I wrote down, but it's probably 18 point something. 0.37? Okay. As long as those are the steps that I see. Not Well, once you sort of see it, you go, oh yeah, okay, right? It's trying to figure out, you've never seen a question really like this. Okay? Okay, I'm going to be quiet now. There's some questions on page 188 in the book. If you're interested in more of these sort of unique ones, which challenge your way of thinking, page 188, numbers 39 to 48. And you've got a few minutes left. You guys did really good today. I think maybe we need to do more of this. Maybe me take questions and force you to work with people. You got it. You guys did at least five questions each today, right? Which for some of you is more than normal. Maybe it needs to be the new normal.